morning everyone. Coming to the module 5 contents of essentials of mechanical engineering. So here we are going to discuss about what is a robot, what is its anatomy, what are the different joints of the robots, and how it is going to work. Industrial robot, it's a general purpose programmable machine possessing certain anthropomorphic characteristics. The most typical anthropomorphic or human-like characteristics of a robot is its arm. Some of the qualities that makes industrial robot commercially and technologically important are listed below. Hazardous work environments, repetitive work cycle, consistency and accuracy, difficult handling tasks for humans, multi-shift operations, interface with other computer system, and it is reprogrammed. So these are all some of the technological importance of the robots. When you take the robot anatomy, it is with assembly of the outer components of robot such as wrist, arm and body. Before jumping into robot configuration, here are some of the key facts about the robot anatomy. So at the base it is fixed. At the joint 1, joint 2, the links are established. So between joint 1 and joint 2, those are known as links. At the end, there will be an arm. So here the robot is fixed with respect to the base. So with link joint 1 and joint 2, with the help of links, it is going to actuate, and at the end of the robot there will be a wrist where it will be able to hold the required tool and carry out the operation. So here end effector, it is the hand of the robot. So end effector is where you are going to add attachment so that it is going to do the operation. It may be pick and place, it may be welding, it may be painting. Like these different operations may be carried out. Robot joints are helpful to perform sliding and rotating movements of a component. Manipulator in a robot are developed by the integration of links and joints. In the body and arm, it is applied for moving the tools in the work volume. Kinematics means it is concerned with assembling of robot links and joints. It is also used to illustrate the robot motion. So classification based on the robot: polar coordinate, cylindrical coordinate, Cartesian coordinate, jointed arm configuration. So polar coordinate robot, it has got rotations at 2 joints and 1 linear motion. So the work volume of the polar robot, it is defined clearly. So above the defined work volume, the robot cannot move. Advantages of this type of robot is long reach capability in the horizontal portion, vertical reach is low. So in the vertical axis, T joint it is there, and in the horizontal axis, R joint is there. So like this, linear motion it happens with the help of the extension of the robot. If you take a cylindrical coordinate robot, the configuration consists of a vertical column related to which an arm assembly is moved up or down. The arm can be moved in or out relative to the axis of column. So this is the EME robot. Advantages is increased rigidity, capacity of carrying high payloads. Disadvantages: floor space required is more and less work volume. If it is a Cartesian robot, it has got the XYZ motion of the robot. It is composed of 3 sliding joints, 2 of which are orthogonal. So here Cartesian robot, here you can see the different axes. Highly accurate and speed, cost is less, simple operating procedure, high payloads, less work volume, and reduced flexibility is the disadvantage. So jointed arm configuration of the robot, it is known as SCARA robot, where with respect to all the 3 joints, the rotations will be available. Only with respect to base it is fixed, but all the motions are, it is in the rotary motion. So this type of robot, it is named the SCARA, is selective compliance assembly robot arm. So advantages, it is increased flexibility and huge volume is required, and operation is quick, but the cost is more, difficult operating procedures, and plenty of components are attached here so that the number of moving parts are more. If you take different types of joints of the robot, it is collinear joint, orthogonal joint, rotational joint, twisting joint, revolving joint. So if it is collinear joint means in this horizontal direction for the input given output it will be there. If it is orthogonal joint means it will be able to move orthogonally. If it is rotational means with input link output link it will be able to move. If it is twisting joint, for the input output link it will be a twisting joint. So if it is revolving joint, input will be with one end and output it will be a revolving joint. So industrial robot applications of material handling, processing operation, assembly and inspection. Material handling operations are material transfer, machine loading and unloading. Processing operations what we carried out with the help of robot is spot welding, arc welding, spray painting, various machining and other rotating spindle process. If you want to carry out assembly and inspection, so you will be adding 2 or more parts to form new entity called subassembly part. This new subassembly is made secure for fastening 2 or more parts together with the mechanical fastening technique or joining process. Inspection, it is automated inspection, automated production and assembly system to inspect the work that is supposed to be done. These inspections accomplish the following function: making sure that a given process has been completed, ensuring that the parts have been added in assembly as specified, identifying place in the raw materials and finished parts,